Hi, welcome to my video on minimum word problem level 2, and this is number 2 on minimum word problems. We have a diagram here, and this information, I drew the diagram to help you out. B is 200 kilometers east of A. So B is 200 kilometers east of A. So B is east. If you think about the compass, east is on the right, west is on the left, so there's 200 kilometers from A. At the same time, a car leaves B and travels west at 20 kilometers an hour, and a truck 100 kilometers from A travels north at 10 kilometers an hour. Find the minimum distance between the car and the truck. Okay, so we have car, and we get the rate of the car. The rate of the car is traveling at 20 kilometers an hour, and the truck, the rate of the truck is traveling at 10 kilometers an hour. You might say, well, that's slow, but it's just a problem. And let's see, if that's the rate of the car, then distance equals rate times time. So distance of the car is the rate of 20 kilometers an hour times t hours. So the distance is 20 t kilometers. And the same for the truck. The distance equals rate times time. So d equals 10 kilometers an hour times t hours of traveling. The hours cancels out, there's here and here, and we get 10 t kilometers. Okay, so what happens is that if the distance that the car is from here is 200, and the car is traveling at 20 kilometers an hour towards A, so that's taking it off. So this distance along here is 20t. So the distance from here to here would be 200 minus 20t, because the car is going east. This is going east. Sorry, the car is. This is east of B is east of A, so the car is traveling west. The car is going this way. So this distance left after a period of time is 200 minus 20t. Now, the truck is 100, so the truck is, let's say, let's put the truck right here. The truck is 100 kilometers north of A, so there's 100 kilometers, and the truck is traveling at 10. So that means that this distance here, so this is 100, this is 10t, so if you're whatever number of hours you're traveling for, you're going to add these together. So this right here is 100 plus 10t, making the distance further away from A. So that leads us with this triangle, and this is a right triangle because, again, this is east and west, and this is north, so there's a right angle here. And we have a right triangle. So that means in this right triangle, we have c squared is a squared plus b squared. C is the hypotenuse, so that's opposite the right angle, so d squared is equal to, and we can take either one of these to be a or b, makes no difference. So let's take 200 minus 20t and square it, and we take 100, which is the other distance, 10t, and we square it. And we simplify this, d squared, we square 200, we will get 40,000, and we multiply this, 20 by 200 is 4,000 doubled, it's a negative 8,000, and negative 20t squared is 400 t squared. So that's that one. Now we'll square the other one. 100 squared is 10,000. You got 2 zeros, make it 4 zeros. 10 times 100 is 1,000. Double it is 2,000. And 10t squared is 100 t squared. Now that we have them squared, now we can add like terms together. So 400t squared plus 100t squared makes us 500. I'm doing them in descending order at the same time. Negative 8,000 and 2,000 is negative 6,000 t. And 40,000 add on 10,000 is 50,000. You can use your calculator. Now that's d squared, but d is the square root of that, and we can go plus minus, but we're not going to go negative distance, so it's 500 t squared, 6,000 t plus 50,000. And we simplify that to make it easier. Let's take 500 out of both of them. So let's take 500 out, because 500 is a common factor. So with 500 coming out, we get t squared. 6,000 divided by 500 is 12 and is negative. And 5,000 divided, or 50,000 divided by 5,000 is 100. And so d is equal to the square root. Let's look at the square root of 500. That's the square root of 100 times 5. So that's the square root of 10 root. Oh, I should have, let's see, sorry about that. Let's do it right here. 10 root 5, and then we'll do the square root of that's t squared minus 12t plus 100. So that's got that messed up there a little bit, but that's the square root right there. And I'll write that down to make it better. So that's 10 root 5 square root of t squared minus 12t plus 100. Now, we want to find it says the minimum distance. So the distance is a minimum where time is a minimum. So the distance is a minimum where time is the minimum. So that means that we're going to have to do the derivative of the inside. So we're going to do d dt on t squared minus 12 plus 100. We're going to do the derivative on the inside of here. So if t is a minimum, then distance is the minimum. So the derivative of that is 2t minus 12. And if we make the derivative d dt on the distance equal to 0, so that means 2t squared minus 12 equals 0. 2t equals 12, so t is 6. And if we have 6, then we have to find the distance. So the distance, let's put the distance into this simplified form right here. So we got a 10 root 5 square root of, we got a 6, so it's a 6 being squared minus 12 times 6 plus 100. So that's 10 root 5 and square root. That's 36. 12 times 6 is 72 plus 100. So that's negative 36 and 100 is 64. So that's 10 root 5. Square root of 64 is 8. So it's 880 square root 5. Or we could go with approximation that it could be, if you want, change it to a decimal, 178.9, and is in kilometers. So that's the minimum distance based on this info. 80 root 5 is exact, or 178.9 is approximate. And again, But I noticed I did that with saying that the time is a minimum, this is a minimum, and the time is a minimum. But if you have done the topic of the chain rule, you know about the chain rule, then I'm going to do this derivative again based on what we call the idea of the chain rule. And that's something that I'm going to talk about later. But if you were more advanced and you knew about chain rule, you could do these problems with the chain rule. So the chain rule, let's do the d prime on this t squared minus 12t plus 100. So we're going to do the derivative and d prime. We're going to change the square root so square root is half power. So now we're going to do the derivative. So the derivative of 10, we have 10 root 5. That's a constant, so we write down a constant. So derivative of this, what we call square root, the half goes in front, so it's a half times 10 root 5, and that's leaves us with t squared minus 12t plus 100. But with the chain rule, and that's to the negative a half, so the half goes in front because it's an exponent, so it's a half times 10 root 5. We decrease the half by 1, so a half minus 1 is a negative a half. But because we have a chain rule, then we have to do the derivative of the inside here, which is 2t minus 12. So that's t squared minus 12t plus 100. So there's the derivative right there. That is a topic that I have to go over thoroughly in more videos later on. So now that I'm using the chain rule, I got d prime is 5 root 5, and this is a half negative, so this is t squared minus 12t plus 100 to the 1/2. Because it's negative, it goes to the denominator, times 2t minus 12. So if we let our derivative equal to 0 to find out where the minimum distance is going to occur, that means we have 5 root 5 all over t squared minus 12t plus 100 squared 2 times that equals 0. And because we have a fraction equal to 0, well, this fraction can't be equal to 0, so therefore, if it's going to be, we have 2t minus 12 is equal to 0. It's the numerator that must be 0. So the 0 must come from here, because we can't get t in the bottom here. So that's one way to look at it. Another way is to multiply the LCD is this trinomial here to the half power. So if you multiply all of that by t squared minus 12t plus 100 on both sides, so you do it with 0, that gives you the 0, and when you multiply here, they cancel out, and you get 5 root 5 times that, and that divided into 0 gives you 2t minus 12 equals 0, because you divide 5 root 5 on each side, and you get 2t equals 12, so t equals 6. So that you could, again, work out this derivative by the chain rule, and it works through. But again, I did it a little bit easier by saying the minimum distance is when the time is minimum, so I did the derivative on what's underneath the root here, and it works out to be the same, 6. You put 6 back in, you get your minimum distance. I just wanted to show you about the chain rule, because some students might say, well, I know about the chain rule, but you didn't use it. Well, You could do either or. And again, that ends this video. And if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.